We got ourselves a deck jack or lift jack, whatever you want to call it. It is a standard size, it looks like, about 17 and maybe 3/4 and 6 inches. So this is pretty much the same size as mine, but it's nicer. It's got the feet sticking out on both sides. Mine only has it on the front. I do not know if this is import or not, but what the problem is, he said, it just doesn't work anymore. So if we put a cranking tool on here, it is extremely bound up and doesn't do anything, and you can pretty much push it down against this like that. So the lead screw, or whatever they want to call it in this, or the block in the back is bad. Where that screw goes through right here, that's the block where the threads are. I've glanced at this, hard to see it, so we need to take it out. I've glanced at this as much as I can see it, and I think the problem is in both sides, the screw itself and in this block. So let's get it apart and find out for sure. He brought it to me because he said normally gets replacement parts for these from V-Twin. I'm assuming he means V-Twin Manufacturing or V-Twin Supply, whatever that company is called. Can no longer do that. They don't have these. My assumption again would be that that's where he got this particular jack from. What we have to do is get this. This is a collar. There's a locking collar on the inside. Then you have a series of washers, a flat, a thrust washer, it's a ball bearing washer, another flat, and the same three, or actually there's a fourth one out here. And that just takes the thrust load off because this holds this screw in place so it doesn't back out against the force of the threads up inside there. Otherwise, it wouldn't do the work. So it has to hold the screw in a fixed position so the screw can do the work to lift this, this part up. Well, I'm guessing it's import because it takes a 19 mil. Yeah. Oh yeah. There is something buggered up in there big time. Holy cow. Holy cow, yeah. It's all galled up. Well, this should, wait a minute, this should come off now. We should be able to get this top piece off. There we go. Then we take that off, Okay, then we got to split the frame here, this pin, and then we can get that out and get it into vise. Well, we got our first complication here. This would have to get spread apart, and it's welded on this end. Well, that is really strange. So they put this together first and then weld it. Well, that's not a complete deal breaker. We can just grind this weld out. There's going to be no saving this, so let's just put a slice in it. Hopefully it'll pop out a little bit. We'll get the rest of that screw out. Wow, that's tight. There it comes. Well, it was. There it is. That's a little screwed up. Screw it. Okay, so I said screw it. I just cut the damn thing right in half. We're going to replace this. I'm going to go off camera right now. I'm going to bang this pin out and take this stuff off the end so you can see this side. This is threaded on there too. I didn't realize that. All right, finally. All right, to get you through this section, which is rather complicated, I'm going to be as brief and concise as possible.
If you believe that, I have a bridge in Brooklyn to sell you.
I know, let the laughter begin. This is what I'm calling the jack screw. This is what I'm calling the jack block. This is the one I slit down there to get it off the jack screw because these are all galled up inside there. More on this in a moment. Now, as far as the jack screw goes, we are going to make a new jack screw for this. And then we are going to make, actually we'll do this first, we'll make a new jack block for this. Now this is a cheap import junk jack with a metric thread, which is M14 by 2.0. I verified that with a metric pitch gauge, because that's kind of important to know this one. 2.0 thread pitch, exactly. And it looks like about 14 mil. Doesn't matter, we'll just use the major diameter of what this is. That way it'll fit everything else we already have. But this end appears to be a square thread of some sort, very similar to an Acme thread or a trapezoidal thread. Now, since this is a metric thread on this end, and this clearly is an import piece of junk Chinese jack, most likely this is a trapezoidal thread. But I do not have a trapezoidal thread pitch gauge, so I cannot verify that.
I honestly can't figure out what pitch this is because I put my standard imperial pitch gauge and also my metric regular thread pitch gauge and an Acme thread pitch gauge on it. It doesn't match up to anything, so it seems to be some screwy metric custom thread or something that's just botched up that they made a matching piece for. I don't know.
I am not experienced at all in Acme or trapezoidal thread cutting, and that is the reason why we are going to make one of these, because I want to use it as a learning experience for me. This side is no problem. Standard 60-degree pitch thread as far as the thread angle goes, and whatever the size is, not a problem. Switch over the metric gears, set it on 2.0 and cut that thread without an issue. This one, on the other hand, is more of a challenge. Now, as far as the thread goes that we're going to use, we are going to change this to whatever that is, trapezoidal, to a 1/2 inch Acme thread. And we're going to use this part that we're going to make first as the thread gauge. Now, to get a tap from McMaster Carr, a 1/2 inch, either trapezoidal, 13 or 4, actually they go from 12 to 14 millimeter. I don't know why they don't have 13, but let's say we wanted to do it at 14 millimeter trapezoidal and just, turn down the ends for the appropriate size for that crap to go back on. You're talking about $260 just for one tap. And I'm not going to spend that kind of money. As far as Acme thread taps go, from McMaster Carr, likewise. A 1/2 inch Acme thread tap is $120, and I'm not going to spend that either. Now, I have ordered a 1/2 inch Acme thread tap off eBay. It is allegedly some sort of open box USA made tap. It is not the step tap like the good ones are, where it does a roughing pass and then a finish pass. Generally speaking, on a trapezoidal, from my research, you don't ever back a trapezoidal out, you just push it all the way through. It has to be a through hole. And I'm going to go ahead and treat the Acme thread the same way. We'll just punch it right through here when we make this. If we can get it through, that's the whole hinge pin here, if you will, is whether or not we can make a hole with a good thread in the square bar that I have ordered likewise from McMaster Carr. This is 1x1, 25 mil by 25, whatever suits you. And if we can put a hole in this with a nice thread, with a 1/2 inch Acme thread with that tap, then we'll do the other turning features on it in the forejaw. But again, I'm going to make this because I do not know anything about Acme threads. And so I said, well, I'm going to have an Acme thread cutter. So I looked on McMaster Carr, which you can buy those carbide inserts for that, but you need a special tool holder. And just one single insert to cut a 1/2 inch Acme thread and the tool holder would be close to 400 bucks. So if I bought those two items, the insert and the tool holder, and I bought an Acme tap from a McMaster car, I could probably buy 3 or 4, maybe even 5 of these damn jacks. So I'm not going to do that. That's a little crazy. This might be crazy enough. But again, as a learning experience, this is what I'm going to do. I'm going to make this jack screw and certainly make a new jack block. So I made a tool yesterday and I did some clips on it. Here's the tool right here. It's only C2 carbide according to this. It's a brazed carbide tool. C2 is not the greatest grade, but C2 is pretty hardy as far as abuse goes. And the only way I could grind this, well, I would put a cutter like this through a lot of abuse. So I'll show you how I did that in some clips. And I'll tell you right now that it's the absolute wrong way to grind a tool. You need a tool and cutter grinder for these kind of compound angles. But I figured out a way to do it, and I think it came out pretty good. We'll go into this tool a little bit more detail after I show you the clips on how I made it.
Okay, so first things first. I am making an arbor in which I can install a diamond cup wheel so I can fixture it in the milling machine. Now, I know what you're going to say. You're going to be like, you can't do that. Well, watch me. This is the end of an axle from a motorcycle axle. It was 3/4 of an inch. And I decided to use this piece because it's got a thread already on one end of it. I believe it is an M14 or an M12. And I'm going to use an 18 mil collet to get this fixtured in the mill, an R8 collet. Now that that part's done, I'm going to turn down, that's the threaded end obviously, to 1/2 inch to fit an adapter that I have made already that I use on my bench grinder, which has a 1/2 inch spindle that cup wheel normally lives as far as how I use it, usually freehand. So I'm making this 1/2 inch for that purpose, and the thread's already there, which I'll cut down the length. Step one is to make the 14.5 degree angle on this tool. This was a 60 degree pointed tool, so I am going to just bring it down to the 14.5 on each side using the protractor. I am just going to bring that carbide down with the steel at the same time. I know you're not supposed to do that with a diamond tool. But actually, I cut high-speed steel with this cup wheel all the time, and the cup wheel is like in really good shape still over in a bench grinder where it's normally mounted. So I just want to bring it down to almost a point at this point, and then do the other side the same way. This is how I'm going to make the clearance. The best I can muster raising the vise up is 3.5 degrees. So I hope that's enough, but I don't know if it's right. I'm sure it's not, but I can just nip the vise down and there you go. But in order to make sure that this cuts right, I have to retram the vise, even with it jacked up at that angle. It has to be square again with the table. Otherwise, I cut a weird angle. After a light tightening, the best I could get is 3.4 out of it, so that's close enough. This is a Max Grant trick that I learned on his channel. What I do here is I'm using a little marker on the carbide, and when it cut this, it should cut parallel to the existing cut. Here's what I mean by that. If you don't have the vise trammed in square, even when it's angled up, what's going to happen is you're going to end up cutting a compound angle, and I need to follow that 14.5 degree angle I've already cut on the tool. Now, it probably would have been better just to do this in one shot. In other words, cut the angle and the tool with it jacked up like this in the original configuration that I did before. But I just didn't think about it at that point because I just wanted to get the 14.5. I didn't even know if this would work at all. So I figured I'd try that first and then do this later. So what we're going to do is show you this little line that I make, and I'm just touching the back edge of the tool. That would be the high side. And I'm going to point to that little line that I have made in the marker, the red marker right there, which is fairly parallel to the existing 14.5 degrees right there. So basically that tells me that I should be very, very close to the parent angle that I already cut. And all I'm doing right now, because I've raked back that metal part on the back side of the tool at 10 degrees by hand over on the belt sander. So all I'm really taking is the carbide and maybe a tiny, tiny bit of that steel at 3.5 degrees. And so that's my goal here, is just to cut that part at 3.5 degrees. And once it cleans up, then I know I'm there, because I don't really want to take any more off the carbide. Yeah, it's a little bit off, but I think it's close enough for what we're going to be doing, because I just can't do any better. I mean, we're dealing with pretty much a piece of crap carbide, raised carbide on a steel tool shank that's not the squarest thing in the world. But we are doing the best we can, and I think it will work. And with that kind of degree angle on it, I think 3.5 is probably okay. We just need a little clearance. And so there we go. We're cleaning it up right now and hitting the camera at the same time, but you get the drift. I do the other side of the tool the same way, so I'm not going to bother showing that. Next setup we're going to be doing is the square end of the tool, and I'm just going to use that same 3.5 degree geometry as far as the clearance on that end. I'll go over the tool geometry numbers with you here separately, but at this point I'm pretty sure I've got the right width flat, and again it's raked back to 3.5 degrees.
Okay, let me assure you that no milling machines were harmed in the making of those clips. I had the ways covered with an old, pillowcase, junk pillowcase, and I've wiped everything down very thoroughly. So this is a standard 29 degree included angle Acme thread tool. It's probably nowhere near correct as far as the clearance angles and so forth, but we're going to try it anyway. Now I have the specs for this tool right here, which I got online, if I can reach the damn thing. And I know the root depth for an Acme 1/2 inch 10. That's, in other words, 0.380 is the root of the thread. I know the pitch diameter too, but I can't measure it because I don't have wires. You know, if I had a 3-wire setup and I could go in there and measure it with the appropriate wires, we could do a pitch diameter, which would be very, very handy while we're cutting this thread, if we can cut this thread with this thing. So we're going to have to kind of wing that one. I do know the tip flat width, in other words, this little width at the end of this tit, is supposed to be 32 thou. I got that as close as I could. And of course, half of 29 is 14.5, so that's what my compound angle will be set at. I already knew that, but I wrote it down anyway. So as far as this tool goes, as you saw in the clips, I had to do some funky comedina on setting up the vise to get these angles. The tool is not chipped out, but that's because the grade of carbide is, as I said, C2. It's fairly hardy, but it's not really designed for steel. But we're going to probably rough this out at the appropriate 10 TPI with a standard thread tool, a 60 degree thread tool, and only go in so far that we don't exceed the width of whatever this ends up being. We can measure that and get an idea. Now, speaking of ideas, if you stick this right in there, see if I can get a good background for you, like right there. This fits pretty damn perfect, and it doesn't have any side-to-side movement when I try to move it that way. I mean, I think it's going to work fine. I understand this is a trapezoidal thread most likely, and they are very, very similar according to what I've read. So I think this will work if we can cut it. But if I rough this out on that 1045 bar ahead of time with, like I said, a regular threading tool, we should be able to clear out enough material so this thing maybe will hold up. But I'm not 100% sure. That's, again, why I'm doing this. I want to learn. And I thought this would be a great opportunity. We will most likely have to use the follow rest with this because it's a fairly thin piece. And we're going to make it out of a piece of 5/8 1045. This nominal on this is bigger than a 1/2 inch. Otherwise, I would just bought a 1/2 inch stock. See, it's 540 thou, which I think is like 13.6 mil or something. I'm sure this is a 14 mil thread. So this is slightly bigger than 1/2 inch. And the center section is slightly under 1/2 inch. It's at 490. So for obvious reasons, I needed bigger than a 1/2 inch. So that's why we did 5/8. So we're gonna have to turn the whole thing down to the largest diameter, which is of course this 540. And we'll fire the camera back up then, take it from there. But that's why I'm doing this, because I just want to learn. I want to see if I can. Simple as that. Okay, so it's time to see if we can do this. Several days later since the last clip, and I've got the tap in stock. Here's the tap drill for that Acme, a 1/2 inch by 10 TPI. And we're going to be making this piece here. 1 inch square bar, that's 1045 steel. And I cut it off just a little bit longer than this piece is. In the bandsaw, I picked up with an edge finder for the x-axis on both sides. Standard stuff. And then on the y-axis, and drilled a center hole. So we're ready to start by just putting this tap drill size down. Something I had in my extra drill drawer. It is really sharp. It's a split point, which is nice. And according to the internet, the tap drill size for an Acme 1/2 inch by 10 TPI, and this is a reference from Machinery Handbook, is between 400 thou and 406. This is a 403. A 10.3 or something like that, 10.6 millimeter drill bit would do it too. I don't have one. I think 10.3. But we're going to use this one because it is the correct size. Now I'm going to definitely be muscling that tap through by hand. But I think I'll start it with the chuck. That way we can get it straight, you know, with the mill. Hopefully. I'm not sure if I can do any of this yet. Like I said, never did it before. So let's just punch a hole through and stop screwing around. Instead of talking about it, let's do it. That is too fast for that. I'm going to go around 600 RPM, I think. That's a nice sharp drill. Success! Let's go ahead and move this crap out of the way. The real success will be if we can get the tap through. I do not know. We might as well be a little civilized and champ for the hole, huh? Okay, a little break in the action. I got some more stuff coming in that we may work on machining wise in the future on a future video. So here is our Acme, jeez, my brain is fried. Our Acme 1/2 inch by 10 TPI. It says USA made. The ad on eBay said it was open box used. No, I mean not used, but in other words, like sitting on a shelf type thing. I would say that this condition suggests that that is accurate, and it seems very sharp. We're just going to put it in the chuck, and I'll show you what I just had to bang something up to see if we can power this thing in by hand. I just need to get it started, straight. And whether or not that's going to happen, I don't know. I don't know anything, but I do know that we got to do something, or this ain't going to work. And if it doesn't work, that's fine. Just scrap it. But it is a fun project to try. I like to try anything at least once, just once. Now we're not running it that fast. Lord have mercy, these phones. Freaking spam, I tell you what. Okay, I'm going to put it in. I'm going to bump it with the, the stop button on this VFD is essentially like a jog button. I'm going to give it a little bit more ass. Okay, that's enough. I just banged this up, using one of these square adapters for a 3/8 drive. This welded terribly. I don't know what the hell the material is, but even with shielding gas, it was terrible. But as long as it don't break, then I'm happy. And we'll see if we can muscle this through. The reason why I don't have a good tap driver, an adjustable tap driver. One that's got, the adjustable jaws that go in on the tap. I just don't have one that's big. Well, not that at least. So I'm going to have to find one of those, like a Starrett or something would be nice, but something like this, we definitely need some leverage. And just take it easy. I mean, it's a lot of force, there's no question about it, so this is going to take a while. Probably not supposed to back one of these taps up, but I think you have to, at least to break the chip once in a while. You know what we can do as well is we'll go a little bit, take it out, blow the chips out, and then start over. I'm going to work on this off camera because I need to move you guys out of the way. I'm going to bring you back when we get to the point where either it goes through or I break it. One of those two things is going to happen.
Stay tuned for the thrilling conclusion of this story.
Tune in next week for the exciting conclusion.
That's bullshit.
All right, all chamfered up. We're going to tap through it again just by hand, and hey, it looks pretty damn good considering. 10 TPI, and I had the proper tap drill size as far as the hole goes. So this thing should have the appropriate percentage of threads for an Acme tap, which I have no idea what it is. 70, 75%, who knows?
Yeah, 220, 221, whatever it takes.
Guess what time it is? Before we do this, I want to show you this. This is the tool I made in the earlier part of the video, and we're going to put it into the fully formed section of the tap. That's pretty damn good. I mean, that fits nicely. There's no question this geometry is going to make this thread maybe a little narrow the way I have it cut, so worst case scenario is we have to bump the compound a little bit and take another cut to get it to proper width, but we'll figure that out when the time comes. Right now we got to set up our rod, which is already cut slightly longer than the other one, the original one, to length. Here's our rough plan. From this end here, in front of the chuck, to that first line, the diameter is going to be 535 imperial. That's going to be for that metric thread, whatever that is. And then from that line there to the next line right there, it's 0.490. It's a little smaller than half. And then the rest of the bar all the way into where you can't see it in the chuck is at 1/2. That's where our thread for the Acme is going to go. We're going to go ahead and cut that 1/2 inch first. I'm going to put a threading insert in to start with and make some witness marks at those two locations there. This bar is exactly at 624.5. I'm going to use an aluminum insert. I'm going to try that. I've used that before on this 1045. This should be 7th hour rev. That's better. Let's try that. 800 RPM. Let's do 40 thou, 20 on a side. I expected that. I'm sure I'm getting some deflection. Surface finish bites. Let's go back to a steel insert. Maybe we'll try this for semi-finished cut and see how it works. Yeah, no way. I changed that to a fresh edge, running at just under 5 thou per revolution. That's better. I just took off 30 thou total, 15 on the side. This end we're at 511 and about 1/2. Down here we are at 511, maybe slightly under, a couple of tenths. And that was, you know, taking a 30 thou cut. I swear this thing cuts straight. I got this tailstock dialed. It's within, we're at about an 8/10 difference with a semi-finish cut from this length right here. Now, of course, the middle is bigger because you'd expect it to be with the tool deflection. I mean, the part deflection, 513.5. It's only 2 thou. Actually, 1.5. So we got like about an 8/10 of a taper from this end to that end, which is, I think that's pretty damn good considering this lathe is, you know, what it is. This part is hotter than a $2 pistol, so I'm going to let this cool off a bit. And I'm going to change the insert one more time, get a fresh one. I'm going to try that aluminum insert again. I already did a test cut with it. It's got a very, very slight nose radius, very sharp compared to the other ones. And then we're going to take the last 4 with it and see if we can improve that surface finish. Slowed the feed down a wee bit. It was a fairly light cut, so let's see how much of a taper it's cutting. It's 504 at this end over there by the tool to your left. 504.5. Maybe 6/10. Okay, let's say 8/10. 504 and 8/10. It's less than a thou taper, which is pretty damn good. I thought I hit record for that final cut. I took 4 thou off, and I didn't. I somehow forgot to hit record. So let me show you the result. Doesn't matter. You've seen enough turning anyway. As far as this end goes down by the tailstock, it's 0.499.5 thou. So half thou under half inch. And this is about 6/10 over. So basically a thou difference in this length taper-wise, which is not too terribly bad considering. Okay, we got a problem. I can't put the traveling steady in because it slants back, and to pull the tool all the way back to start the thread at the end interferes with the live center. I tried to dead center, but it won't reach. I could extend the part out. I do not want to change the setup because I know this is turning concentric to the chuck now, and just moving it a little bit, even if I don't rotate it, it's going to screw that up. So that's worse than taking a chance, I think, on any chatter. But we're going to rough it out anyway. So we'll just do it as is. And this is the tool I mentioned earlier. While we, while we had that abomination set up in the mill the other day with that, that cup wheel, I went ahead and set up the tool holder with just a regular threading tool in it. If I get down on it, I kind of pulled the center out, or the sides out of this, and just left the center of a regular 60-degree cutter. It's not wider than the root of the thread. As far as the calculations go, it's what they are. I couldn't find my notes, so I had to look them back up. But I expounded upon them, and since I'm set at a 14.5 degree compound angle, and I have squared the tool off to the chuck, we have an infeed of 60 thou if it was straight ahead, and 62 thou at 14.5 degrees because it has a 1.033 multiplier because of the angle of the dangle. And then start taking a cut. If that holds up, we can kind of dig out the center of this thread and then put the tool in there that I ground, which is up here, and try that. So let's give it a few passes with this, and I'll shut the camera off and come back when we're going to start using the actual tool, if we even get that far. See what we got. Running 270 RPM and standard threading operation. So let's go. think I'm gonna have to slow that down a little bit as far as that RPM. At 10 TPI, that thing cranks. Yep, it's good to me. I'm running 200. Try that. That's a little better. Okay, you get the picture. Well, that's hot. I'm gonna go and whittle away at this off camera, and when we get close to the end, I'll bring you back, if I can remember to turn the damn thing on. Well, I broke the cutter at the end here because I didn't clear the cut, and when it came around, normally on a regular threading tool, it's not a problem because it's full form. And it'll just cut a groove, essentially cut a clearance. And I broke it, so I reground another one. Picked up on this, and I went in about 10 thou more, but unfortunately I lost my setting as to where exactly our depth is. I can only estimate it at about 45 thou. We need to go 50 would be safe, 50, 52. So what I'm going to do is I'm going to lay a pin gauge in here. It'll fit. This is at 45. It won't fit in there. If I lay this in like this and just take a thread pitch, or I should say a 60-degree gauge, and just do this. Yeah, it's bigger than 30. Let's try to find whatever one and give me a little drag. There's a drag, man. I'm going to say like 32 because it's just a little bit proud. Okay. And again, the difference between 380, which is the minor diameter, and the major diameter is 120 thou. Divided by 2 is 60, and that's a 62 thou compound infeed. That would be max. And we would get near that and then try the piece on there, but at least we know where we're at. So I'm going to go ahead and set my compound for 32, and then I'm just going to keep going.
What'd you do?
Well, that other cutter broke about down here. I'm lined up on the actual tool that I ground as close as I can get to this existing, core out, if you will. See what happens. Go 7 thou. And just go in with the compound this time. Set a 0 in the root. That's fine. I'm going to do that again. I picked up off the major diameter with the tip of the tool. I'm going to advance that until we hit the root. Make a note of that number. Okay, at that point, then I know how deep we are. And then we'll just make the adjustments. Because if I change the compound in relationship to that, we're going to be off. We'll be off on the sides because the compound's at 14.5 degrees. So that's the easiest way to do this. And just factor it into the math. Okay. $22 thou. Yeah, say 24. That way we can just factor it into the math on the compound. We already know how far we're in then. And I can just come back to 0 now. Let's give it a shot and see how it does when we're taking a cut down the length with this actual tool that we ground. Yeah, let's see what happens. I don't have a good feeling about this. Just take like 3 or 4 thou. Take a few more. I think you get the idea. Let me concentrate on this. Bring you back when either we have a catastrophic failure again, or we get pretty close to being done. Oh, great. Whoa. Trying to climb up on the damn cutter. Let's take a spring pass. I mean, it's not bad. It looks pretty good. Let's try checking it with the piece, wherever it went. Oh no, we're still tight, but it's getting there. Definitely getting there. All right. Not too shabby. Okay, that, according to calculation, that should be 52 thou on a in-feed, compound in-feed, that is. And of course the thunder's coming, and of course the dog's gonna get all freaked out. Let's give it a test fit, since we're getting kind of close on this. See where we're at. If we're anywhere. It does not seem to want to start straight. Well, that's, maybe it's because of this burr out here. Yeah, it's not anywhere near close. Won't even try to start. That's okay. I guess we'll just keep going. I know I'm not to depth. Maybe that's got something to do with it, don't you think? Storms we've been having lately have been absolutely crazy. Whoa, that's too much. I backed off on the X3 thou. I'll go ahead and put it back to 0 and take a spring pass. Wants to climb on the cutter once in a while. Like that. Like that.
Aw, fuck.
Oh well. There goes our cutter. Crap. Well, kind of expected that was going to happen because of this damn carbide. The C2 shit. Oh well. And, of course, we were so close, too. Another couple of passes, and this would have been a done deal. Man, that's a damn shame. Well, I'll tell you what I'll do. I'm going to try to find a an Acme half-inch die, like on Amazon, even a cheap piece of crap. Because if we're this close, we should be able to finish this off with a die. And then have ourselves a working screw. Because, like I said, we are very close. I mean, that was the reason why I wouldn't thread on at all before. We were just too far away. But right now, we're starting good. I mean, we're just starting. So, I'll go try to find me a die. I'll do that later on this evening. We'll continue it at that point. But, you know, the concept worked. I mean, I'm happy about that. I don't know what happened. I got greedy or something. We just took too much off and... yeah. Oh well. I'll see you in a little bit. You know, before I put you away, though, nobody puts baby in a corner. This screw looks pretty damn good, except for right there where we had it a little faux pas. I mean, this ain't bad. Considering how I ground the thing, if it had been a better grade of carbide, it probably would have held up. I mean, that's really not bad at all, considering. All right, good morning, folks. The next day we have a change in plans. Last night I did some research on trying to obtain an Acme 1/2 inch by 10 TPI die just to clean these up, as I indicated in the last clips. I was only able to find one hit on Amazon, and the reviews indicated it was a piece of junk, and I'm not going to take a chance of ruining these fairly nice threads so far with a piece of junk die. I could get one from McMaster Carr, but it's extremely expensive. Everything else I found online was either not an Acme thread, and they were talking about it being a trapezoidal die, and also an Acme die, which that really can't be the case. It has to be one or the other. I know they're very close, so maybe it sort of is, but anyway, the net sum is I abandoned getting a die to chase these threads because of the aforementioned reasons. So we're going to recut it using this tool, which I reground. I'm going to go ahead and zoom up on it and explain what we're going to be doing here, because it's going to be a little different. Okay, so this tool, as you know, I ground on the mill with that, what do you call it, the cup wheel, the diamond cup wheel. I ground this by hand, but only on this side. I put the cup wheel back on the bench grinder. This side was at 14.5 degrees, and it still is. I didn't touch it, and I used a protractor to get this side in as close to 14.5 as I possibly could. I also dusted off the end here to be as square as I could for the root of the thread. Now I ground this purposefully narrower than what the resulting width of this thread needs to be. I got to kind of give you a little background on these types of tools to explain why, so you understand. In case you're going to do something like this, that's the only reason why I'm doing this. If you take a look at threading tools in general and other types of tools that make a particular geometry or pattern geometry on a workpiece, these are really form tools. Like a radius tool would be a form tool, like a button head insert or a button insert, it's a form tool. And a threading insert is basically a form tool. It forms a particular geometry in the workpiece for that particular purpose at a certain TPI, depending on what your machine is set for when you're screw cutting, single point screw cutting. And this is probably your worst case scenario with a threading tool, i.e. form tool, is when you have a flat end in the root, a square thread, and you have a 14.5 degree angle on each side, and you're trying to cut this on all three of these parts of this thread. Essentially, you're trying to bring in the pitch diameter as well as the minor diameter. And of course, the major diameter has already been done when we turn this down to 1/2 inch. And that's the reason why this thing snapped in the first place, because I had this thing pretty close to the width it needed to be. And so the cutting forces and the tool pressure are just too much. This part is too thin. And as I said before, I cannot get the traveling steady in, which is what you really need in something like this. Because over here, you're relatively well supported. And down here, you're supported a lot better because you're right up by the chuck. So this is the area right here where you're going to have most workpiece deflection. Now that can kind of save you in a way and hurt you in another way. Because it might push the workpiece away and lessen the tool forces, the pressure forces, but it also has a better opportunity to climb up onto the cutter and damage the workpiece or the cutter. It happened down here, I believe, because that's what was happening. We were pushing the workpiece away. So this is probably a larger diameter than this is. And when we got up close to a supported part of the workpiece, it dug in. And because we were cutting essentially on all three parts of this cutter, the depth of the root and both of the sides of the pitch, it just couldn't take it and snapped it off. Plus this carbide's junk anyway. So when I reground this, I reground it purposefully narrower than before. And this is one of the recommendations that I read online about how to screw cut single point an Acme thread. The two recommendations were to rough it out first, which is what we did until we broke that cutter, both of them. And also to use a narrower cutter and essentially take and develop the thread 1/2 at a time. We're going to basically set the compound at 0 degrees. So it's going to be straight at the workpiece and straight at the spindle. And then we are going to pick up on this thread and we're going to cut it in stages. So once we have the compound at 0 degrees in line with the workpiece, we can use it to bump the tool, which is narrower than this thread width right now, the pitch diameter width. And we can use it to cut the inside of this part and the inside of this part in separate operations, separate passes. We can essentially kind of mimic that. If I show you very carefully here, we can bring the tool in. So we're going to be moving the compound essentially either away from the chuck or toward the chuck to get this side of the pitch diameter and this side of the pitch diameter in separate passes, as I indicated before. And when we get to that point, we will be doing the minor diameter by simply sweeping that back and forth. It may only be about 1/10 hour moving, but if we cut on one side of the tool at a time, we have a much lower potential for it to snap this tool off even if we're in the root. So that'll essentially be two sides of the cutter, the tip of the cutter and one side. We'll be doing the work instead of three. That should be enough to keep this thing from trying to climb up on top of the tool here and snap it off again. And we should be able to make enough passes to get the width and also the depth, you know, as far as the root goes. Now, it would really be beneficial if I had, I could measure over wires and actually utilize that pitch diameter, but I do not have any wires. This would be a perfect situation for that, because measuring the pitch diameter as you go would give you an idea of how much you needed to move each way to achieve the objective. Because if we go too far and the pitch diameter is too wide, then essentially the thread's not going to be right. You know, assuming that tap cut it okay. I would imagine that tap probably cut it a little bit big. They always do. So this way we can kind of dial it in. So that's going to be the plan. I got gas. We're going to pick up on this thread. I'll do that with you really quick on camera. All right, I'm going to go down to 70 RPM. I got to bump this tool post up so it's hanging off the side, in this case, of the compound, which isn't the greatest situation, but the only way I can get it to reach because the tool is not long enough. Story of my life. So, but we do have enough clearance. We can do this. So I can actually move the compound on the Z-axis now and do what we need to do. This is really not too difficult to do as far as picking up an existing thread. When it comes around to my number, I'll engage right there. So we're a little bit forward. Let's come back. We'll advance in on the compound a little bit. Try to get right inside that sweet spot. I gotta move you a little bit so you can see and I can see. Pretty good right there. I'm almost up to the root. See? Okay, I'm going to zero the compound dial now. Okay, so I got the X zeroed on the cross slide. So I'm basically touching the root or very close to it. And I've got the dial zeroed on the compound. So I know I'm basically in the center of it. Now we'll go ahead and disengage and come back. Come back, baby. And then we'll come back up to 0. Okay, let's use the pin method again like we did yesterday and get an estimate on what our depth is. This is a 42 thou pin and it fits quite loosely there, but not here. It's actually about a little bit small, or a little bit big rather. We definitely have a big variance in the depth because, again, this is workpiece deflection. And down here we are about dead nuts on 42. So what we need to do is follow the largest or the greatest diameter spot, which again is in the middle. So it's bigger than 42, it's probably around 40. I'm going to go with 40. So if we're just touching the root, we need to clean this up first and get that depth before we start screwing with the sides. In other words, even this depth out. So that's the first thing I'm going to do. I'm just going to run the tool in and make sure we're not touching on the sides or not very much. And we'll see if we can take very light passes so we're only touching the root and see if we can clean up that and even out that depth. And I said the wrong pin diameter. The pin diameter I was just showing you was 45, so it's probably around 43. Let's see how we can screw this one up. And that's good and tight? Yeah, good and tight. 0, 0, so we should be just hitting that, and we've lined up. So the only thing to do right now is, well, actually I'm going to second guess myself. I'm going to come off and bring the cross slide in while it's moving. I'm going to go back to 70 to do that first. Engage!
Engage.
Yep. Let's go back and go up to speed. I'm going to go to 200 RPM again, set back on 0. We know we're good. You know, the workpiece has not come out of the chuck. We're definitely still in sync, you know, in sync. And one other quick point here, I did remove that dig in the thread where it broke the tool yesterday. See what happens. Yeah, it wasn't hitting hardly anything. Oh yeah, taking some now. Not quite there. Whoa. Shit. I was in between damn gears. Well, we're gonna have to regrind it again. Stupid mistake. It would really help if I stopped making stupid mistakes. Somehow, I did not tighten or not tighten enough the tool post onto this tool holder. That wasn't the problem. The problem is engaging up here. I'm down to a diameter now where I can't go back here because I'll be hitting the live center. In other words, that root diameter where I'm at right now is actually below the diameter of the center over here. So I have to start right there. And there is virtually no wiggle room if you get it in between the half nut off the number that you want. So it's either I run it at 70 RPM or we come up with a different way to do it. I'm going to choose the latter, and I'll show you that here in a sec. The pin says we're at 46. DRO says 47. Close enough. We're going to treat this like a metric thread on an imperial lead screw. I'm going to leave it engaged in number 1 to start the cut, no matter what we're doing, even if we're cutting either side of that 14.5 or this root, because I just can't take this chance, and there's just no wiggle room here, and sometimes you miss your mark on the thread gauge when it's turning at 200 RPM even. If I had like 150 on this lathe, which it really needs a VFD, that's something I want to do for the future, but I don't have that opportunity right now, so let's move it around till we get where we want. Okay, now we're in 1. So we're at 47. I've made sure that we're still in the center of the cut. And of course I had to regrind that tool. Let's try it, see what happens. I'm going to try it at 70 first, just to make sure, and then we'll take it from there. Leave it engaged and just go up to 200. I'm chicken. All right, I think we're close enough, cutting all the way down, where we're going to start doing the edges as far as the width of the thread goes. Yeah, we're just taking off a little on that inside edge. 5 thou. I think we can stop in time if we leave it engaged and come to the end. So I went back to 0 and then went over to +5 on the compound. So now we're that way. Let's see what it does once we can get lined back up again. Okay. That time we were able to get it in pretty solidly. See what happens. 47 thou. Okay, since we're down this far, let me go ahead and try checking it with the piece. Okay, baby. Oh, we got a burr there, don't we? Ah, crap. That's where I smashed that tool, I bet. We are really, really close. I'm so close. I'm gonna degrease the end here with some brake clean and put some Dykem on it and see exactly where this thing is tight. I suspect it's gonna be tight in the root because we are not to depth yet based on the numbers. I mean, it's actually pretty damn good, but it ain't good enough. A little bit in the root, but we got that burr. I gotta take that burr off. Let me get that off first. All right, that's solved, which I should have done before. That was stupid. We are definitely getting tight. Tight. So, trying to figure out if it's the width or the depth, though. That's the problem. I don't see a whole lot of action on the pitch of the thread, but the root I do. So, I think my theory is accurate. I think we just have to cut that root deeper and we'll go up to the numbers. Tell you what, I have done enough of this on camera. You've already seen that. So I'm just going to go ahead and off camera get this root brought up to where the numbers say it's supposed to be, and then we'll come back and see how it works. Okay, I believe I'm really close on the depth. So I'm working on the width. I've taken one pass with the compound back away from the chuck, 5 thou again. Try this side now because, you know, since I had to regrind it, I had to recenter the tool. But only time is going to tell. But we're getting real close on this. It's a complicated thread, these Acme threads. They really are. They really are. Yep. A little bit more than I'd like on that. We'll let it ride. And that's the whole problem with recentering the tool. But now, since we've taken a cut with that tool at that center, then as long as we don't break another tool or something, we should be able to work off that. Okay, we are much further, and I'm much more lacerated from this live center. Okay, so I believe I've determined that it's the pitch diameter, the width of this thread that's the problem right now. So if we line this tap up here where the threads are most developed on the back edge of it, they're that major diameter right there, you see? We're not going down to the root. So essentially what we have here is a failure to communicate. And we need to go wider on that pitch. Try it out. Yeah, we're definitely taking a little bit off the that front face thread, and a little on the root. I don't mean Stephen Root, the actor, either, even though I really enjoy him. Not that that matters. Now, if anything, we're taking a spring pass on the root, but we're definitely cutting on that back face, so positive Z. There is just no room for error here at all. Here we go. Went to 7 thou, negative Z. So we're cutting on that following face again. Same depth. Okay. Now that really does look pretty damn good right there. I'll show you later. Let's do a little blow job first. Freaking oil everywhere. I just cleaned this stinking lathe up like yesterday before we started this, as far as you know. Wow. This goes up all the way. I'm going to eat my shorts on camera. And we're starting to get a little bit bindy, but we're moving. I got to back off some more. I need some clearance. Look at that. Minimal play. A little bit. Oh, wow. Oops. Tool's in the way now. Oh, wow. Look at that. Now that is pretty damn slick. I mean, that's a really nice thread. Oh, yeah. I think I could stand here and play with this all day, except the edges are damn sharp and I'm going to cut my hands up. As far as you know. Let's see. And right there I feel a little bit, but it ain't enough to be a problem because we got to soften these edges anyway with some sandpaper or just a file or something, just lightly. Minimal movement. Wow. Holy cow. I actually single point cut, screw cut, an Acme thread, ultimately hand grinding half the tool angle and using junk C2 carbide and no expensive tools. Ta-da! Let me give you a close-up of it all cleaned up. I want to show you this using the tap as a thread gauge. You got to look at the back of the tool where the tap is, whoops. You got to look at the back of the tap rather, where it's fully developed. Now, yeah, there's a little difference in there, and that's something that I know I could have done. I'm fully aware that you can take these taps and essentially make a single point tool out of these. You can even cut them down to like 1 or 2 threads and figure out a way to fixture them into a tool holder so they're, parallel with the workpiece like this. All you have to do is make sure it's rotated in the right location so it's actually got either neutral or slight positive rake, and then just have them move along at 10 TPI. I considered that, but this wasn't exactly an expensive tool as far as the tap goes, but it wasn't cheap, so I don't want to ruin it, so I'm going to keep it. Bind up or something under load, under use? Well, I don't know. We're going to have to finish this up, which I'll do off camera, and then reassemble the jack and try it. Because, this is a very precision thread as far as its functionality goes. But for what it is, I think it might just work. All right, so that's it. I got this all back together. I jumped ahead. Didn't think you needed to see me reassemble it, considering I fumbled my way through the entire process, and it works really well. I'll go over some details with you, but you got to come down here to do it.
Well, first, here's a shot of the finished jack screw before installation. I just want to give you a really clear picture of it. All the threads are great, even the metric threads on this end, which are, of course, single pointed. I just think the thing came out absolutely beautiful.
All right, first things first, here's the old jack screw. There's a hole down through toward the end here that lined up to this, and you can see that hole is fairly close to the very tip, this end, just the tip, just for a sec. And so there really wasn't very many threads in this. And I made sure that it was long enough where I could actually get this screwed in a lot more, drilled through it. So on mine, it's probably about there. A lot more threads on this. Drilled it straight through, as I said, bang that split pin in. Before that, of course, I put the collar on. I'll show you that when we flip it over. It has a similar dimple like this one does for a regular grub screw. Really should take a dog point, but it doesn't have one of those. But it's just more of a pointy tip one, which is okay. So that's not going to go anywhere. It's all tightened up. Of course, here's the old block, and again, we'll see that in situ and in functionality here when I flip this thing over. I'm going to give this stuff back to him so he can see what I did. As far as function, speaking of the devil, this thing works really good, really well. I mean, this end here is, I don't know what this is. I tried to put this in a V-block to put it on the mill to do this hole. I ended up doing it freehand. This isn't even, these aren't even at the appropriate angles. I don't even know what it is. It doesn't even take a standard wrench. 11/16 barely goes on. I don't know what it is. This is a 3/4. It's kind of loose, but it works. If I spool it back down, you can see that this thing really is I mean, it's very nice. If I put some load on it, which I can't really load it up 100%, I wish I could, like put, 500 pounds or something on it. I don't have a way to do that, so we'll just have to let him test it in real world circumstances, but I mean, it's nice. When I put the compression on this block out here that this thing goes through, I made sure that it just snugged it up, and I got some grease in there, and that's where that collar is that has that set screw, that grub screw. Okay, let me jack her up and we'll spin it over. I'll show you the bottom side. I had to make some changes to the jack screw block on this end over here. I just kind of misted it with some paint that I had on hand just to cover up the bare steel, but it's good enough. But this is what happened with this. When I shoved that tap down in there, even though I started it on the mill, when I lined this up, when we were on the lathe, and I was test fitting this, I could tell, but I didn't say anything at that point. This block was crooked as far as to these two surfaces that the hole goes through. So the tap must have walked a little bit. And this is fairly close tolerance in here, so there's not a lot of room for slop, for compensating for it being kind of like this. Well, the solution to that was just put it in the mill. And what I did was I put the tap back in and then used a square, because the tap goes in pretty firmly when it's at full depth, at full form thread depth. And then with the square, got the top of it squared up to the tap, which of course angles this. And I simply milled the top, spun it around on some parallels, milled the bottom. And the reason for that was because when I put it in the forejaw to pick up on the center of each side, if you quadrant this out, so this would be one quadrant and the opposite sides would be another. With an indicator, if this thing is cattywampus in there, then those round features with these bushings go over, these rollers, would be out. They'd be kind of like this. So I couldn't have that, because then it just wouldn't be right. So right now it's as close to right as it's going to be, and I got some grease on it, and she just really is fantastic. I mean, the thing really came out great. I'm real happy with the thread on both the jack screw and the jack block. We'll get you down a little lower so you can kind of look up inside under her skirt, so to speak. And you can see down inside there where we have that collar. So this is an undamaged portion of the threads because it never got up that high. And you can just look at these threads. They're hardly developed because they're not machined. They're rolled, put in some machine and rolled. And you can see my Acme half-inch 10 TPI is very well developed, and it's going to be an absolutely much stronger joint here as far as this thread into the jack block goes. So there's no question. I mean, this thing showed it was rated for 1,000 pounds. The tag came off, capacity 1,000 pounds. With that screw, my ass, it's a 1,000 pound capacity. It actually might be now, you never know. Oh yeah, let me show you some. Now certainly this is an offshore piece of junk jack, but so are mine. And here's one of mine over here. Now if you take this one, you wiggle it side to side, that's pretty damn sturdy. But take a look at mine. I think I may need to do some maintenance. Of course, these have pretty much always been that way. And this is all tight, this is all tight. I mean, this is actually a pretty good jack now. I mean, it is now, it wasn't before, so yeah, there you go. So I had a lot of fun doing this, and I learned a lot. It's quite interesting what you can find that you can do just with stuff that you have in your workshop. Doesn't necessarily have to be, an actual tool and cutter grinder. It doesn't have to be high-end milling machine, horizontal boring mill, tool room level lathe or anything like that. You can do some quality work if you take the time and you just think about it as you're doing it. I'll show you my high-tech diamond cup wheel grinder that I use to grind that tool, the one side of the tool by eye and by hand. The cup wheel you saw me use in the mill. I'll show you where it normally lives. Well, it normally just lives on top of the generator there underneath the bench, but when it's in use, this is where it lives. I have a piece of angle bolted to it. It just clamps in the vise. Plug it in up there in one of my plugs. And I know the bearings are not so good, but this is an old bench grinder motor. So I have the rougher one and a finer one on this side. And that's how I ground that. This was my original bench grinder. I've had this one for a long time. And this is my dad's old one that I took from the house a couple of years, 3-4 years ago when I was up there on the big trip where I brought back Dad's old bench and other stuff. My brother said, "Do you want Dad's old bench grinder?" And I said, "Yeah, it's probably better than the one I have, which was an old Craftsman, which I repurposed to somebody else. They're probably still using it for all I know." So I got a magazine in from one of the clubs that I belong to. I wanted to show you real quick because it kind of applies to what I want to say in this outro here. I want to say up front though, this is not a sponsor. This is just a club that I belong to. This is the Vintage Japanese Motorcycle Club. I think it's a bi-monthly magazine. It's a great organization. If you want to join the VJMC, I'll put the link to it right here. Mention my name when you join. I don't remember my member number, sorry. And I'll get something for it. I don't know. I don't really know what it is. It could be a cookie. It could be a glass of lemonade. It could be a kick in the ass. I don't know. But they give you something, like after a certain number of people that refer to a particular member, they give you a free renewal. I don't know what it is. Let me show you the cover though. This is the cover story. And it is, of course, you can read it yourself. Alan Milliard, artist or engineer. And I was reading this morning. It's a great article. So if you go and join the organization, you can actually look at this online if you want. But let me talk about this briefly because, again, it segues to what I wanted to say here. I have long mentioned on my channel here doing kind of specialized things that seemingly are not necessarily impossible, but difficult, especially with not having, specifically designed equipment. For example, a tool and cutter grinder to grind that Acme thread tool. I was able to do it anyway though. And the reason why I'm able to do that is because I think about Alan Milliard, a guy who does all this really crazy, amazing stuff. It is art, and it's certainly superior and sophisticated engineering in a garden shed and some other, maybe a garage, a little shed or something like that. I think he's got a garden shed and another building on his property with small buildings, and he doesn't have much different machine tools than I do. And he comes up with all this really cool stuff, and I'm sure everybody watching my channel already knows who he is. So I look at that, and I look at him, and I have said this many times. If Alan Milliard can do it, I can do it. And you know what? You can too. So thanks for watching as always. Don't just repair, restore. And we'll catch you on the next video.